Hi everyone, I'm Senan, and in this video we are going to see how to delete the head of a doubly linked list, right? So before that, be sure to follow this series because I've implemented inserting at head, tail, and at any position, and this is the deletion segment of that series. So whenever you're trying to delete a head in a doubly linked list or even in a singly linked list, you have three cases. Case number one is where your list is empty, so you have a null list. Case 2 is that you only have a single element, which would be the head itself, and the case 3 would be you have more than one element. Okay, so let's discuss each of these cases and what do we have to do in that. So if we have case number 1 where the list is empty and I'm saying that delete at head, so since there is no node, so we don't have to delete anything. In that case, we would just directly return. Case 2 where we only have a single element and I say that delete head. So what would happen is you would remove this single element and what you would be remaining is this again a null list. Now one thing to note that here is that initially the head would already be null. In this case, head is actually pointing to this node, but when you delete that, you need to update the head to what? To null or heads next, this node, which is a null node. Now when you have number of elements greater than 1, that is the case 3. When you delete this node 1, say you delete this node 1, you need to keep track of a couple of things. First, when you delete this, you need to update the head to this node 2, which is the second node. Next, this previous pointer of the next node should now point to null because there is no node here anymore after deletion. Because when you delete this node 1, this is trying to point to a memory location in your system. And after deletion, that memory location is not accessible to you anymore. So this pointer would now be a dangling pointer, which we don't want. So what we do is after deleting this node 1, I would assign this previous pointer of the next node to what? To null node. And I would assign the head to the second node. And we're done with that. So see, I have implemented this class doubly linked list. So I always have the access of node within these functions. So let's write what? Void delete at head, and you would take nothing as input because you know where to delete and what to delete. So let's do the case 1. So if I try to delete head, which is already a null node, I just return directly. Fine, because there is nothing to do. Or rather than checking head is double equal to null, I can just say if not head. So if head is null, not head is a true value. So if not head, that means if head is not null, you return. Now let's do case 2 and we'll also do 3 together because the logic is simple. So we'll do those or we'll combine those two cases into a single one. So now after this statement, after this if statement, I know I have at least one node in my list and that is a valid node. So what I'll do is I'll create a temporary node that would actually be pointing to the next element, next of node, right? So if the case is 2, then this temp would be pointing to this null node. And if case is 3, this temp is pointing to this node. Now what I need to do is now delete the head itself, right? I've deleted this node and I've deleted this node, either of the cases. Now, one thing I have to keep in mind is that if I am in case 3, I need to reassign the previous node to null. So how would I do that? Is I would do that temps previous is equal to null. But this is only possible when if temp is a valid. If temp is not null, only after that I would perform this operation, right? So this would take care of our two cases. If temp is null, we won't go into this if statement and that would conclude our case to be case 2. Otherwise, if temp is not null, we have more than one element. So this temp would be a valid node. And for that, you'll assign the previous to null because you've deleted the very first node. After this, it's simple. You assign this head to this temp. Okay. So what you do is you reassign this previous link and you delete the head node. And if you see, heads next is null in case 2, heads next is a valid node in case 3. So this if statement in itself would take care of both of these cases and I don't have to tamper with the remaining part of the list because it is not required at all. Okay, so that was the delete add head function. Now this, let me just clean this up. And if you see, the code is very simple, code very short, and it's always a good practice to return even in void functions. So what is the time complexity? So in this case, if you see, all of these statements are order 1 statements, right? And since these are order 1 statements, the total complexity would be order 1, because we know the number of order 1 operations, it's constant. So that's it. What about the space complexity? Again, it's order 1, because at max we are declaring a few variables and just this. Now the space complexity is not taking care of the length of the linked list, right? Keep that in mind. That is the function. Let's just save this and let's go to our main function and see and try to do this. So DLL dot delete at head, and let's say we call this a couple of times. So cout after deletion, and okay, so I would call this delete at head, and then I'll just print the linked list, and I'll call this a couple of times so that we are able to see that, or we are able to see the effect of this function. So let's just compile this main.cpp, and after that I have the executable, so a.exe, and print this. So see, we called the constructor for this statement, then we inserted the elements 1 to 10, and then we printed that. So this is the printing of the linked list, and after deletion is this cout statement, and we have deleted at head. So we have deleted 1, then we have deleted 2, then 3, then 4, and then 5, and yep, then we returned. So after returning, this object is destroyed, so therefore destructor is called, and yep, that's it. So this is as simple as it could get. It's order 1 operation, it's constant time, it's constant space, and the code is very simple, just a few lines of code. So that was the video all about. Hope I was able to explain this to you. The next video we'll see deletion at tail, and then after that deletion at any particular position. So thanks for watching, and I'll see you in the next video.